On to chapter 3, where we're going to deal with graphing. Here's the title page, little shot of the Eiffel Tower. These are the sections that we're going to be covering in chapter 3. And here we see our first graph, where we have on the left here tourists in the millions, and then the years on the bottom. And this is usually true. Time is along the bottom and amount is up on the side. And you see tourists worldwide, the number has been increasing. Okay. And the trend is up. On to chapter 3, section 1. As I've mentioned before, we're going to give an overview. I'm not going to read the chapter for you, but we'll be commenting and taking some of the words out here. So reading graphs and the rectangular coordinate system. And we use graphs a lot. So reading a bar graph to start us off. Well, as you look at it, what jumps into your mind at first view? Well, internet users worldwide, the highest is Asia, Oceania, and Australia. And the least, Africa, Middle East, and it easily jumps out at you. Again, that's the nature of a graph. Try to give you a visual of something, and depending what they're asking here. Let's go. Find the region that has the most, which we did. How many more users in North America region than in Latin America, Caribbean region? Let's see here. All right, so this looks like about 190 right there. And North America looks like 260. So maybe 70 different. Again, when you're guesstimating, it's kind of a challenge. And again, you wouldn't be able to pick out those numbers directly from this graph. I'm assuming the one that you get, you can make it really big so you can be a little more accurate. Okay, but that's how you do it. You kind of estimate where this is, estimate where that is, subtract it. Now another kind of graph is the line graph, which you're seeing here. Smoking versus pulse rate. So here you've had some data, and then you are looking after that data is plotted, and then you're asking someone to look at it here. So again, time is along the bottom, or the horizontal axis, and pulse rate or amount is the vertical. What is the pulse rate 15 minutes after a cigarette is lit? So you go here to 15, you go up, and then you go over. And again, it's a little hard to, if you had a ruler or a straight edge. Actually, I have a line. So let's see here what we can do with a straight line there. Sort of something like that. So we don't really have the mark. So is that 82 or so? When is the pulse rate the lowest? Well, it would be here at about 58, and that's at before you started to smoke. That's interesting. I guess here you're anticipating a smoke, and It goes up a little bit. When does the pulse rate show the greatest change? Okay, the greatest change would be right in there. Okay, so that's between 0 and 5. All right, let's take a look at what they're saying here. So once again, you would go to 15, up over, and then over there, about 82, 83. And it's actually before lighting up is the lowest, which we said. And the steepest is between 0 and 5. Okay, we were good. All right, defining the rectangular coordinate system and plotting ordered pairs. All right. So what they want you to do here, and a lot of this is background. Well, I've put a set of parentheses and I put the letter X, comma, Y in there. Now, since in our society we read from left to right, our X is first and then our Y. This makes up what is called an ordered pair. So as you look at the graph, you would go over to 15, and by the way, this is referred to as the x-axis, and this is the y-axis, and we then can plot these points or read them from there. So our x value here would be 15, and they're saying that's going to be 80. Okay. And each of these then can be positioned on the graph using the ordered pair. And often what I like to do is create the rectangular coordinate system by doing this. We're going to have a number line that goes this way, and in the middle of that number line we're going to put a 0. And we know that to the right of 0 are positive integers, to the left negative. And then we're going to take another line and go vertically. Oh, I didn't do that one very well. Let me do that one again here. There we go, that's better. Go vertically, again, through that 0, and we're going to put arrows to indicate it keeps going on. And again, another vertical number line. Above it are positive, below it are negative values. And then notice these two number lines have divided the rectangular plane into 4 regions that we call quadrants. This will be our first. This is our second. This is our third. And this is our fourth. And we use Roman numerals to designate the quadrants. And the ordered pair where they intersect is called the origin. And the values of the origin are 0, 0, or the coordinates. And the horizontal line we're going to call the x-axis. And the vertical number line we'll call the y-axis. So we've created the rectangular coordinate plane. And I think we've covered most of the things there. Again, all of this is covered right there. But now, again, there is a protocol, a way to do it when you plot ordered pair points. As we mentioned above, it's x comma y. And if you had a point 3 comma 2, the way to do it, you would start with the origin and then plot the x, which is over 3, and then the y, which is up 2. And if you did negative 2, 5, you would start at the origin, go left to negative 2, then up to 5. And that is something you'll be practicing and practice, and later the quiz me, and hopefully that's the easy part of all of this. And you might say, does it matter the order? Well, again, by definition, an ordered pair indicates that order does matter. And if you switch them around, you get two different points. So keep that in mind. So here they're asking, plot them, and then also state which quadrant they're in. Now, if you plot them correctly, you know, it's first quadrant, second quadrant, third quadrant, fourth quadrant. And notice some are on the line, they're on the axes. So those in which the first coordinate is 0, we say these are on the y-axis. Where the first coordinate is a number, but the second coordinate is a 0, those are on the x-axis. And of course, the origin is on both. Okay? And I'll let you look over this and you'll be practicing that. Now, an interesting thing is that depending which quadrant you're dealing with, and we can use this one as an example, here both coordinates are going to be plus. Here the x is negative, but the y is plus. Here they're both going to be negative. Here the x is positive and the y is negative. So depending on the signs of the coordinates, you can actually tell which quadrant they're in. And once again, if the first value is 0, it's on the y-axis. And if the second value is 0, it's on the x-axis. And you'll get some practice of this as well. Now, often in our real world, when we hear about things, it comes in pairs. That in a certain year you had this much, or a ticket sale cost this much at a certain time. So we think of paired data. So in example 4, they're giving you the annual net sales in billions of dollars for Target stores. And you see them here. Now, with this data, can you make a graph? And the answer is yes. And we call that a scatter diagram. And I guess they're going to do that for us here. Yes, there it is. So it's to take the data, and again, on the, usually most graphs are in the first quadrant. So along the x-axis is time, or years, and the the vertical axis, the up and down, that's the y, will be amount of sales, the year. Now, this little item here we mentioned before indicates you're leaving out a portion of the graph to feature what you're interested in, which is the topmost parts of it. And there's the scatter diagram of the data we saw above. You'll be asked in MATLAB to do one, and usually it's picking one out of multiple choice because it'd be hard on a computer to put that in there. And there's just another one. All right, another objective we're going to look at in this first section of Chapter 3 is to determine whether or not an ordered pair happens to be a solution or makes the statement true. We did some of these in Chapter 2. We said, is 4, for instance, would that make this true? And that is yes. But now we're going to have an equation often that's going to look like this. AX plus BY equals C. That later we'll find out is the standard form of the linear equation in two variables, x and y. And remember, we have our ordered pair xy. So what they're going to do is give us a value, x and y, and then we're going to substitute that value into the equation they give us, which in this case is 2x plus y equals 8. And the value they're going to give is 3, 2. So what we do is we take our 3, and where the x is, we put the 3 there. And where the y is, we put the 2 there. So 2 times 3 is 6, plus 2 equals 8. And yes, that is true. Okay? Now, we say then that the ordered pair 3, 2 is a solution for that original equation, which was right there. Okay? And then we will proceed. And here we're asked to determine whether each ordered pair is a solution of this equation. So you might say, well, what would the strategy be for this? Well, it would be to write the equation x minus 2y equals 6. And then where the x is, you're going to put a 6. So this then becomes 6 minus 2 times 0. Does that equal 6? And since this is 0, 6 equals 6. So this one is yes. Now, if we put the other pair in, this would be 0 minus 2 times 3. Does that equal 6? And we get a negative 6 equals 6. That's not true, so this is no. And then this one, let's write it over here. X minus 2y equals 6. So our x is 1. And I'm going to write that as 2 over 2, which is a 1, because I have fractions there, minus 2. Well, maybe I don't have to write that. Let me change my mind, because I see something that's going to happen here. So we'll just use a 1 there, minus 2, since I'm going to cancel out here, a negative 5/2 equals 6. So here the 2's are going to cancel out. That's why I didn't need that. And then negative times a negative makes this a positive, so I have 1 plus 5 equals 6, and that one's true too. And you might say, how can such different numbers be true for the same equation? That's something we're going to explain as we move on. And again, the second one was false, the third one was true. All right, now we're starting to get into the mechanics of all this. And we're looking at example 6. Here we have our equation, 3x plus y equals 12. Now they're giving us only a piece of the ordered pairs, only one member of the ordered pair. A good way to organize your data for this, and they'll mention this a little later on, is what I call to make a T-chart. A T-chart looks like this, where we put an X there and a Y there. Now it looks like a T in a sense. And we have 3 items of data. So our first one here is a 0. So we'll put the 0 under the X. Here this is going to be a 6. And then this is a negative 1. So what we're going to do now is put these values into this equation and then solve it. So if x is 0, this is 0, 3 times 0 is 0, then all we're left with is y equals 12. Now if y is 6, we may have to write that out. Some you can do mentally. 3x plus 6 equals 12. 3x equals, I'm going to transpose the 6. That makes it a negative 6, so this is a 6 then. Divide both sides by 2. X equals 2. And if x is a negative 1, we'll probably write that one out too. 3 times negative 1 is negative 3. Putting a negative 1 where the x is gives me a negative 3. Plus y equals 12. Y equals, transpose the negative 3. This becomes a 15. So what we have done, by the way, is taken 3 possible points and find the missing member by putting it through substitution into our original equation, solving then for the other letter, and organizing our data in a T-chart. So for the first one, we got a 12, right there. For the second one, we got a 2, right there. And I'm assuming the next one, as we see it, will be a 15 on the next page. There we go. Okay. Now they're introducing us to the T-chart. So you want to have practice of doing this. So you would write y equals 3x and then a T-chart. And they're saying negative 1, 0, and a negative 9. Okay, so maybe you could do this mentally. It's kind of an easy equation. If x is a negative 1, 3 times negative 1 is negative 3, y equals negative 3. If y is 0, divide both sides by 3, you get x is 0. And if y is a negative 9, divide both sides by 3, x equals a negative 3. And you can put that 3 times negative 3 is negative 9. And there is your chart completed. So there's your negative 3, there's your 0, and we'll go on. And there is your last point. Okay? Now you're going to be doing lots of T-charts. Again, you want a strategy to do it. You write the equation out, make your T-chart, and then solve those little equations. If you can do it in your head accurately, that's fine. Otherwise, you need to write it out. All right, here's another one, perhaps a little more challenging. And since they have it all worked out here, I don't need to write it all out. You'll be reading it too. So here x is going to be a negative 2. Now, as we go on in this, let me just give you a little point of view here. And often they're not going to give you some points like this. You have to supply that. Now, for this equation, and let me just make 2 T-charts here because I'm going to tell you the difference here. Traditionally, the points we choose are like a negative 1 for the x, a 0 always, and maybe a positive 1. Now these are near the origin and are going to be easy to graph. If you choose big numbers here, you go off the graph. But when you look at this equation, again it's in 2 variables, y and x. When you look at this equation, would you choose a negative 1 and a 1? And the answer is no. Why not? Well, because of the 2 here, you're going to end up with a fraction. So when you see that there is a fraction somewhere in there for your x value, choose a number like negative 2 and always a 0 and a positive 2 because of that fraction being there. So when you put that in there, and they're choosing one too, because that'll cancel out. So if you put a negative 2 there, the 2's cancel out. You're left with a negative 1 and a negative 5, give you a negative 6. And if this is 0, 1/2 of 0, you're left with a negative 5. And if this is a positive 2, again, the 2's are going to cancel out. This becomes a positive 1 and a negative 4, a negative 5, give you a negative 4. Now, they didn't ask it that way here. They said, what if y is 0? Well, if y is 0, you have to bring the 5 over to the other side, and you get 1/2 x. And then you just multiply by the reciprocal of 1/2, which is 2 over 1, and you get 10 for this one here. Okay? Now you probably wouldn't choose 10 in this column because it's might be off the graph. Again, you want to choose things toward the origin. Although this later you'll see we will be using these two values, a 0 and a 0. These have special names. We'll get to that later. Okay, finding the value of a computer. Here they're saying a company recently purchased a computer for $2,000. And they say generally it's going to be used, frequently during the weeks and months. And then as it's used, its value depreciates. And they've come up with this particular equation to show, because of this being negative, that the line of the graph is going to go down. And they say, what is the value then of this computer through your time period, which happens to be the X? So when you start, that's brand new computer, this is going to be, as they give you down here, 2000. When it's 1 year old, the X is 1. That becomes a negative 300. That's 1700. When it's 2 years old, then the X is a 2. That becomes a negative 600. This is 1400, and so on. Okay? And that's how you would do this particular example. So actually, toward the end of the 5th year, the computer is only worth this much. Okay? And then they can write it off their income tax or whatever. And this is what the graph of it would look like. Okay, that completes section 1. We spent a lot of time on it, but hopefully it gives you a strong basis for moving on to the other sections of chapter 3. Keep up with your practice and quiz me.